Hello everyone, this is going to be a quick digital lesson on graphing quadratic functions. I'm going to show you two different methods that you've already seen before, so you should just be able to take some quick notes and move on. So first, what is a quadratic function? A quadratic function is defined by this formula, f of x equals ax squared plus bx plus c. Now, the graph of a quadratic function, as you all know, is always a parabola. Every parabola is symmetric around a line called the axis of symmetry, which is the x-valued line that goes directly through the vertex. The intersection point of the parabola and the axis of symmetry is called the vertex. That's one of the reasons why the vertex is so important, because it is where the axis of symmetry goes through. Leading coefficients, that's basically the number in front of the x squared. When the leading coefficient is positive, the parabola will open upwards, and the vertex will be a minimum. When the leading coefficient is negative, the parabola will open downward, and the vertex will be a maximum. You should write those two things down somewhere because you're going to need to know them. If you need to press pause, but I'm going to move on to the next thing. The standard form for the equation of a quadratic function is given by this formula. Again, this is important. You should write this down. F of x equals a, parentheses, x minus h quantity squared plus k, and a cannot be 0 because if it is, then you have a straight line. You don't have a parabola. Now, here's how you graph an quadratic function that's not in standard form. So we're given the parabola 2x squared plus 4x minus 1, and we want to find the axis and the vertex, and we want to graph it. So the first thing we have to do is we need to factor out a 2. Now notice that I put parentheses around the two variables, the 2x squared and the 4x, and I factored out the 2. I didn't do anything with the 1. Then I'm completing the square on the inside. So I looked at the 2x. Half of 2x is 1. 1 squared is 1. So I added 1. But I'm not really adding 1 because of the 2 on the outside, right? It's 2 times 1. So since I'm adding that, I have to subtract the 2 at the end in order to maintain balance. Then I'm going to factor and simplify, and boom, there's standard form. Now, once I'm in standard form, then I can graph it. X squared, it opens upward because the 2 is positive, and then you can identify the vertex as at -1, -3, and you can graph it. Very quick, very easy. The hardest part is the completing the square, and that's algebra, so hopefully you'll be able to be good at that. And there's your vertex, and there's your graph completely labeled. Let's do one more. So I'm going to graph and find the vertex and the x-intercepts. Remember, put parentheses around the negative x, around the x squared and the negative 6x, and then I'm going to factor out the -1. Now, look at the 6x. Half of 6 is 3. 3 squared is 9. So I'm going to add 9 on the inside. However, with the negative on the outside, I'm not really adding 9 to the problem. I'm subtracting 9. So therefore, I have to add 9 in order to maintain balance. Next up, factor and put in standard form. Finally, once you have that, since a is less than 0, the parabola opens downward. The vertex is at +3, +16. And then you can sketch your graph, and there's your axis of symmetry. So this is method number 1 of graphing a quadratic equation. You can also find the x-intercepts by solving and factoring and figuring out where things go, and that gives your graph a little bit more detail. And more detail is always better. Method number 2. Method number 2, we want to find the line of symmetry. So here it is. You're given a quadratic equation in standard form. The equation of the line of symmetry we've talked about in class is x equals -b over 2a, and this is best read as the opposite of b divided by the quantity of 2 times a. So for example, if you find the line of symmetry for this equation, we would use -b over 2a, so we'd get 18 over 2 times 3, so we get x equals 3. So the line of symmetry is x equals 3. To find the vertex, now we know that the line of symmetry always goes through the vertex. So if you're given the line, if you find the line of symmetry, it gives us the x-coordinate of the vertex. To find the y-coordinate, we just need to plug the x value back into the original equation. So we find the line of symmetry is always the first step. Step number 2, plug the x value back into the original equation to find the y value, and therefore you find the vertex. All right, so step 1, axis of symmetry. Step 2, find the y value so you have the vertex. Once you have that, Step 3 is to find 2 other points and reflect them across the line of symmetry, and then you connect the 5 points with a smooth curve. So there's 3 steps. Step 1, find the line of symmetry. Step 2, find the vertex. Step 3, find 2 other points. And you make a table to help you do that. So let's do a complete example. So step 1, find the line of symmetry. X equals negative b over 2a. So it would be 4 over 2 times 2, which is 1. There's the line of symmetry, and I drew it with a dotted line. Next up, you're going to find the vertex. So since the x value is given by the line of symmetry, we're going to plug in x equals 1, and we're going to solve for y, and we get negative 3. So the vertex is at 1, comma, negative 3, and I put an open circle, a dot, over there on the dotted line. Step 3, the final step, find 2 other points and reflect them across the line of symmetry. So since the vertex, the axis of symmetry was at x equals 1, I chose x equals 2 and x equals 3 for my other 2 points, plug them into the equation to find the y values, put them on the line, and then I reflected them across the line of symmetry, the axis of symmetry, connect the 5 points into a nice smooth curve, and there you go. So 2 different methods for graphing quadratic formulas, and hopefully you got that and you understand that and you remember that from Algebra 2.